Hello everyone, this is going to be part 2 of the exam for review. In this one we're going to start with some of the problems in rate of change up to when we get to inequalities. So the first problem, we have a cylindrical water dish that is 4 inches deep and has a radius of 3 inches being filled. So if the water in the dish is 2 inches deep, how much water is in the dish? So to calculate this, we use the volume, which is given by pi r squared d, and so in this scenario, b will be pi times r is 3, so we're going to use 3 squared, and we know that the depth is 2. So overall, this is going to be 9 times 2, 18 pi, and this is going to be inches cubed. Now, B1 and B2 are going to represent the amount of water when the depths are D1 and D2 respectively. We're going to find a formula that expresses the rate of change dV dt in terms of the volume dV dt. So for then, let's calculate first the two volumes. So the volumes will be pi times 9 times D1, and B2 will be pi times 9 times D2, because what is changing is the depth. Okay, the radius is the same. So when we calculate the delta V is just going to be essentially 9 pi d1 minus 9 pi d2. And so if we factor 9 pi, we get, sorry, let's make d2 minus d1. We get 9 pi d2 d1, and so we can see this as 9 pi delta d. If we apply on both sides the delta of the change of time, dv dt is going to be 9 pi dd dt. And so that is an expression that will give us everything dv dt in terms of dd dt, but we want the opposite. We want the ddt in terms of this, so we got to flip this 1 over 9 pi to the other side. So we can see this as dd dt is equals 1 over 9 pi dv dt. And now on C, we're going to work that under assumption that dv dt is going to be a constant. Okay, so because we had this from before, we're going to have that the dt is this amount k over 9 pi. Now k here is a constant, remember. Now in D, they tell us, well, what about if that constant is actually 3, meaning 3 cubic inches per second? So what we do here is we can replace this here by 3. So we're going to get 3 over 9 pi, and this will be 1 over 3 pi inches per second. And so that's the end of problem number 1. It's not a lot of different things. We are doing a step-by-step. Normally what we will do with a different scenario, but just breaking it apart in multiple pieces and doing each of the considerations in a different part. Now number 2 is approximation of the area. Okay, and so in here we have the function 8 minus x cubed, and we want to approximate with these 4 rectangles. So it says if you were to find the area of the rectangle shown, will be the area larger or smaller than the area under the curve. This is something that we don't need to do anything to see. We can see that we have more area with the rectangles than when the area under the curve, so clearly this is larger. And now to find the approximation, we actually need to find out what points are we going to be using. So for example, it all depends on the height. So this height here can be 0, f of 0. And then the second one is going to be 0.5 f of 0.5. And the third one here, the height of this one, is going to be 1, f of 1. And this point height is going to be given by 1.5 f of 1.5. Okay? So now if we find those actual values, we're going to find out that this is the 0.8 point. Plugging 0 in f of x gives me f of 0, which is 8. So the point here is 0.8. If I plug 0.5 in this function, I'm going to find out with my calculator that this is 7.875. For if I plug in 1 and f of 1, I'm going to get that f of 1 is 7. And if I plug in 1.5, I get this is 1.5, 4.6, 4.625. So now we have the coordinate y here, the f of x, is going to give me the height of each of those intervals. And we clearly can see that each of these measures is going to be 0.5. So the sum of this R1, R2, R3, and R4, these 4 rectangles, is going to give me the approximation area. And that's going to be what? So R1 is going to be 0.5 times the height of this one, which is 8, plus 0.5, 7.875, which is the second height, this one. The third one is going to be 0.5, 7. And the fourth one is going to be 0.5 by 4.625. When we add all those numbers on the calculator, we're going to get that this is 13.75. Notice that you are doing here the points on the left side. So we're using 0, 0.5, 1, 1.5. But we can easily do the other approximation with, let's say, 0.5, 1, 1.5, and 2. So it all depends on the type of area that you're approximating. In this scenario, we're going with those particular points. Now, question number 3, we have a trapezoidal pen is being divided into sections. So the diagram of the pen is here, and the dimensions of the pen are labeled. So the pen should enclose 500 square feet. So that's pretty much the enclosing of the two areas is going to be 500 square feet. So what is the meaning of that? The meaning of that is that if this is a square part, so 500 should be equals to those L square plus, and the triangle here measures L by W over 2. So that is the area of enclosure. Okay. We want to know what is the value of W if L is 10 feet. And so one of the things that we can do is replace L by 10 in here. And so we're going to get 100 and then 10W over 2, or 100 plus 5W. Okay, and so this means that 400, because I subtract this 100 from here, is equals to 5W, and then W is going to be 400 over 5, and it will be 80. So if we assume that L is equals 10, we're going to get that W is equals 80. Okay. Now, for the second part, we want to know what is the total amount of fencing that is needed for this. Okay, and so notice that we have 10 here, 10 here, 10 here, 10 here. And we find out that W was 80. And so we have almost all the dimensions. We have 4 times 10 plus 80 from this little piece. We're only missing this part, but this part is like a hypotenuse of this triangle. So we can find it by doing 10 squared plus 80 squared, which, getting the square root of that, this is going to be 80.62. And so the total fencing is 4 times 10 plus 80 plus 80.62, which is around 262 feet. So notice that everything that we're doing is accounting for the dimension. Here we're seeing how much of the fencing was needed. Over here we find out if we had this much of the length, how much was going to be the width, and those type of things. Now, number 4 is another problem about fencing, but here we get to talk about the dimension and expressing different things. So we're going to express what is the total number of the total amount of fencing that we have, and we're going to go for the area. So if F represents the total fencing needed, we can see this as 1, 2, 3, 4, 5 W, right? And we need 1, 2, and 3 L's. So this expression, which it gives me the perimeter, it gives me also all the amount of fencing that I need. Now, using the fact that the total amount of fencing should be 180, so they're telling me 180 is 5W plus 3L. Let's express W in terms of L. So they're telling me, well, solve for W. So 180 minus 3L over 5 will be W. Now it says write an equation for the total area A in terms of L only. So what is the area? Well, the area is base by height. The base is L. The height is 2 W's. W here, so it's going to be twice W by L. But since we know that W is this, then we can write twice this times this. Okay? So here says find the dimensions that will maximize the area of the pen. So there are multiple ways of doing this. I already showed you in class what can you do with Desmos and with a calculator, right? But of course you can also do this with a quadratic and finding the vertex. So this here can be seen as minus 3 over 5 L squared plus 360 over 5L. Okay? So if this were going to be a quadratic of the type ax squared plus bx plus c, the vertex occurs on the point minus b over 2a, f of minus b over 2a, right? If this is the function f. Over here, instead of x, we have L. And instead of C we don't have, we have 0. But we can see that B is this value here. So here, the vertex will occur at the point minus 360 over 5 over twice minus 3 over 5. And whatever f of this point is, I'm gonna call this a. So for now, I don't care about that. But our minus and minus are gonna go away, and the 5 is gonna go away with the 5. So this is gonna be 360 over 6, which let me see. which is going to be 60. So 60f of 60. So this will give me the maximum amount in terms of this. But let me actually confirm with Desmos. So f of w is equals, or f of L is equals minus 3 over 5 L square plus 360 divided by 5 L. Okay. Here we have our maximum, and it's occurring at 60, 21, 60. I have everything okay here. Oh, I didn't multiply this 2 by this here, so I have a mistake. So I have a 6 here instead. So this should be 6 over 5. Okay, so this should be a 12, and this should be a 30 then. And so to confirm that, we should put this here, 60. Okay, did I lose my graph? Okay, here we go. So 30, 100, and 1080. So where did you get that 180? You plug, of course, this 30 in this function here. All right? And so that will be the maximizing of the area of the pen. But at least you should be capable of finding this function with the area. This is the minimum that you should be able to do. Since in the exam you're not going to have a calculator, or you're going to have Desmos, then most likely you will not need to do this part, but it's always good to know how to do it. Now for question 5, we have some of the absolute value formula things. And so if you remember, the absolute value is about distance. So the absolute value of x is the distance to 0 of x, right? So if we're doing the absolute value of x equals c, we're saying that some point has distance c to 0, but that's only going to give me a couple of points, c and minus c, right? And so if I have the absolute value of x minus a is c, then that means that for some specific point a, I'm moving at distance c. So I'm going to a plus c, or I'm going to a minus c. So these are the 2 points that gets me. And if you remember the rule, then and what that means, that will be that x minus a is equals c, or x minus a is equals minus c. And so you see that this gives you a plus c, and this will give you a minus c, which are the 2 points that we're checking here. So now if we're going to solve, we'll use this for solving equations. It's always good that we have it in this type of arrangement. So we should isolate the absolute value. So here we start by doing 2x minus 2 is equals 3 minus 1. We move this 1 from this to this side. And so that's going to be equals 2. And so now we're going to divide by 2 both sides, and we're going to get x minus 2. 2x minus 2 equals 2. Divided by 2 on both sides, x minus 2 is equals 1. And so that gives me x minus 2 equals 1. or x minus 2 equals minus 1. And so that implies that x is equals 3 or x is equals 1. Okay, which makes sense. Points such as the distance from 2 is 1. We have two of those, 3 and 1. Now for part B is very similar. I don't have to do anything strange. So I'm going to start by isolating the absolute value. 3 to x plus 1 is equals 16 plus 5, which is 21. And so now we can divide by 3. So 2x plus 1 is equals 7. Divided by 3, 3 goes away. Divided by 3 becomes 7. Now at this point I can break the absolute value. This means 2x plus 1 is equals 7, or 2x plus 1 is equals minus 7. So this will imply solving here that 2x is equals 6, and then x is equals 3. And in this one, it implies that 2x is equals minus 8, or that x is equals minus 4. Okay? And so that takes care of this type of equation with the absolute value. Now when we have inequations, different things are going to be happening. So now let's actually go ahead and continue with the inequations. So the inequations, they go by the rules of the absolute value. And you got to remember, if we're talking about distance, when we talk about the distance of x to A is bigger than C, then we're saying from the point A, you measure the distance, and it gotta be bigger than getting C. If we get C, we get to A plus C, and we get to A minus C, right? Those are the 2 points in distance. But since we're going bigger than, then we're going with points that are further than that. And that's an entire interval. So what are these intervals here? Well, this is the A plus C infinity, and this is the minus infinity A minus C. If we think of this in terms of points, this is x less than A minus C, and or x bigger than A plus C. If we fold the x minus A to have the original equation, we get x minus A less than minus C, x minus A bigger than C. So this is the rule that represents the bigger than. Okay? So using that here, we get, first we isolate the absolute value for x plus 8 is bigger than 8. Then we divide by 2, we get x plus 8 bigger than 2. And this at this point, we get either x plus 8 is going to be bigger than 2, or x plus 8 is going to be less than minus 2. So notice that this here is x bigger than 2 minus 8, so minus 6. And here x is going to be less than minus 10. All right, so now another one where we're going to have this same kind of rule is C. In C, when we're isolating the absolute value, it's more comfortable to move the absolute value to the other side. So we get 2 plus 16 is less than absolute value of x plus 1. So we get absolute value of x plus 1 bigger than 18. So that means x plus 1 bigger than 18, or x plus 1 less than minus 18. Okay? Remember that this is what the bigger than means with this relationship. And so this is x bigger than 18 minus 1, or x less than minus 18 minus 1. So at the end, I'm going to get x bigger than 17, or x less than minus 19. You don't put this together because the or means that they're separated. So they're a union of two different intervals that they're not together. Now, last we have for this particular equation, and so we have 3x minus 4 less than 16 plus 5. So this is 3x minus 4 less than 21. We can divide by 3 and we get x minus 4 less than 7. But again, we got to think of this as the notion of distance. So what is the meaning that the distance to 4 is 7? So from 4, we meet 7 here. So 4 plus 7, and we meet 4 minus 7. So what are really this point? This is 11, and this is minus 3. So what we're saying is, hey, if the distance to 4 gotta be less than 7, it means that it's between minus 3 and 11, and include the extremes. Okay, so this is equivalent to x minus 4 is less than minus 7 and bigger than 7, and that is translated to x is bigger than minus 3 and less than 11. And this is the answer for this one. Remember, all here is tied to the concept of distance, and being bigger than equal is going to be completely different from being less than equal. Okay, so x minus a less than c is equivalent to a plus c, a minus c, and look in the middle of that, and that becomes x is bigger than a minus c, x is less than a plus c, or x minus a is between minus c and c. Okay, so these two rules are completely different depending on the distance, and you should memorize what they mean, or what this absolute value means in terms of distance. So that's the end of part 2 of the problems.